All right. Well, welcome everyone to a special edition of a SIG Node meeting focused on a number of the resource management topics that we wanted to talk through as a SIG to help chart a path forward. We're trying to do something a little bit different here to higher cadence. The meeting is recorded for those who can attend, which I know is not a perfect time. We'll look to get the recording up later this afternoon, and hopefully we'll use this forum as a way to more quickly triage through things. I'm going to hand it over to Victor, who can talk through how we're maybe plot out a way to make this work, and then we'll go through the first presenter. So go ahead, Victor.
All right, thanks, Derek. Hello, everybody. Yeah, so this is going to be just a temporary set of meetings, and we're going to go through some of the KEPs in detail. I think today the first item that we have is the memory manager KEP. Let me see if I can pull that up and share it, and we'll get started.
Just maybe a point of order, Victor.
Yep.
The agenda doc that you and I had put together yesterday as like a way of maybe trying to structure this. Has everyone had a chance to review that? And maybe we can just set expectations on how we wanted to time box the forum. I don't know, Victor, if you'd share that out.
Yeah, let me share that, and we'll talk about that for a minute. If I can find, oh, there's a share button. Okay, can you guys see what I'm sharing?
Yes.
Yeah. Okay.
Yes.
Yeah, so let's go over sort of the guidelines. So we'll use this, over the next few weeks to share the ideas and approach that we're going to look at the different KEPs and take them back to SIG Node. So prior to each meeting, what we're going to do is look at the agenda, and if there's no agenda before the meeting, we will cancel it. Again, this is just intended to be a temporary set of meetings. It's not an ongoing long series. And so that's why sort of the ground rules are set. Now, at the end of each meeting, we'll also look and see, have we triaged everything that's open? Are there other proposals, other topics, to sort of decide if we need to meet again? And if we do need to meet again, is a week too far out? Do we need to meet sooner? And if there's no agenda for 2 consecutive meetings, we'll cancel the forum and just go back to the regular SIG Node meetings. And again, the intent of this meeting is to have a higher, faster velocity, to look at new KEPs, new ideas, and not sort of overwhelm the SIG Node meeting with these in-depth discussions. And it gives us more time to talk about these topics. Sort of the organizers so far, it'll be me, myself, and Derek. Jay is volunteered to help out, and so is Kevin. If there are others that want to help out, please speak up, and we can add you to the list. Are there any questions sort of about the how we're planning to do these meetings and the agenda? Any questions on that?
The only question I have is one I brought up to you yesterday, Victor, about the Slack channel. Yeah, go ahead.
Yeah, so I had a chat with Derek. What Kevin is asking about, we created a topology-aware scheduler channel. I think it was last week sometime. At that time, it was more thinking about, there's a lot of discussion and interest and talk about NUMA-aware scheduling. And so when we created the channel, that was sort of the name that was there. And I think what Kevin is saying, hey, does it make sense to have this topic here on that channel, or should we rename the channel, or should we just stay in SIG Node? And I had a brief chat with Derek, and the consensus there was to keep it in SIG Node. If that's okay with everyone, we'll continue with that. And I guess we can keep the topology aware channel just for that discussion, which the topology aware channel may involve other SIGs also, like SIG scheduling. And I think the idea was to keep that channel there and just use SIG Node for this particular discussion.
Yeah, that makes sense. I hadn't thought about the fact that, and it's true that the topology aware scheduling stuff's going to touch a lot more SIGs than just SIG Node. So it makes sense to have its own channel in that respect.
Okay. All right. Great. Any other?
And maybe some other context was for those in the past, and those that might not be familiar, like a working group has like a formal meeting in Kubernetes governance that like is supposed to be time bound and spans SIGs and doesn't necessarily own code, but maybe some recommendations. The intent here was not to go and build a new many month working group effort right now. Maybe the output of this will be, hey, we should do that. It was really more to just get through the list of topics as fast as possible and respectful of the author's time so that people aren't delayed. And so like a Slack channel and that type of thing is sometimes like associated more with the working group and the overhead that is associated with being a new, I guess, official body within the Kubernetes community is not as trivial as what we're just doing here, which is just holding.
That makes sense. So this is kind of a potential precursor to that if it evolves into that at some point.
Yeah.
Got it.
All right, great. Any other discussion before we move on to the today's agenda? No? Okay. Can you see the memory manager's presentation, or is it still over on the?
Sorry, yes. I have one question before we jump into this. Can you go back to the other document?
Yes.
I don't think it's there yet, but it'd be nice to get a kind of full list of all the things we already know about that we want to discuss here. Like Derek just mentioned, you know, there's a long list of things. People were presenting a bunch of stuff in SIG Node. There was never enough time to dedicate to it. So it'd be good to get that list here. So we, you know, even if we're not presenting it today, we have the ability to go look at it and links to it, and we can be thinking about it independent of when it's presented.
Okay. That sounds reasonable to me. I'll just make a note here. If maybe even during the call, if some folks already know of stuff, and I know there's like the, well, there's the pod level single-numa-node. If you have a future topic that you want to talk about, maybe you can just add it here and we can have a heads up and maybe look at it ahead of time and work it into the schedule. That sound reasonable?
It's kind of a combination in my mind of future topics plus just all topics that we do talk about in this.
Yeah, I think just even copying over some items that we know we previously discussed in SIG Node that I'm assuming after I'll take Alex's presentation yesterday. I think my hope is that we'll look at all the ideas in totality and just having a record of things that might have been related in the list sounds good. So yeah, if Alex just wants to put a pointer to his doc there from yesterday, that would be awesome.
Okay, great. Anything else before we go to the memory manager cat review? No? All right. Okay, so with that, let's move to the memory manager presentation. And if you're ready, go ahead and I'll just move the slides when you're ready.
Yes, so hello everybody. I think this presentation will take like 20 minutes. Memory Manager is a new component in Kubelet ecosystem devoted to enable cross-NUMA guaranteed memory allocation for pods in a guaranteed QoS class. And this is the team that was working on that and should be acknowledged. And yeah, we should thank as many thanks to Artemov for implementing POC proof of concept. Okay, we can go to agenda. So yes, that's agenda. First, we'll go through our present overall goal and motivation, then concept and design. And here we'll focus on cross-NUMA design because, in fact, it was out of the most interest, and many people were asking about this design. And then we just go into details of the implementation, and I will show also how to generate how to memory manager generates cross-NUMA hints by some examples. Then just summary, and we gathered some additional things in appendix. Okay, we can move forward. The goal, yeah, next. So just to recall, because I think many people are familiar with the goal of NUMA-aware alignment. Just to recall, so the overall goal is to achieve NUMA-aware alignment of container resources across multiple NUMA nodes. So the overall goal encompasses various resources such as CPU, memory, huge pages, and devices. And in this presentation, we'll focus on NUMA-aware memory alignment, also across multiple NUMA nodes. Just to rephrase, in other words, we demonstrate how to provide guaranteed memory allocation for a container in a guaranteed QoS class on multi-NUMA node machine. Okay, we can move forward. So motivation, what's motivation? This is just an excerpt from reference number 1. The reference number 1 it might be a little bit outdated, so in fact I will be working still on the CAP to enhance its readability. Yeah, CAP will be the most up-to-date resource for memory manager. Okay, so just back to the motivation. I will just highlight these 3 points. So it is for many important use cases like DPDK databases. It's also important in the context of 5G rollout for high performance backup processing applications. And in the context of huge pages that can be used for queuing in these applications. Okay, we can move forward. Okay, just concept and design. So our initial concept was limited to single-NUMA policy and, in fact, to memory consumption from a single source, that is a single-NUMA node. And that naturally, the question arises, what if a pod requires more memory than, in fact, a single-NUMA node can provide? And this gave motivation for cross-NUMA memory allocation. And why we were stuck at this with this initial concept, because the Linux kernel does not support cross-NUMA memory allocation to the best of our knowledge. And we thought that we have to wait for a suitable upgrade in the Linux kernel to enable cross-NUMA memory allocation.
Sorry for interrupting. So what do you mean here in this context, cross-NUMA allocation? You mean limits in the C groups or something else?
It will be explained in the next slide, the cross-NUMA allocation, okay?
No, not the cross-NUMA allocation itself, but the missing feature from the kernel.
Because the kernel cannot guarantee that, for example, if you want to use several NUMA nodes, kernel is not able to guarantee that at each NUMA node, particular value of memory is guaranteed.
I put this. I put a comment on this particular slide, but I think you mean to say that the kernel does not support cross-NUMA memory pinning. not necessarily allocation.
Well, pinning it support. It doesn't support the limiting. The C group doesn't allow to specify different limit by different node.
Oh yes, that's the best description, I think. So yes, there is no, you cannot put limit on individual nodes if you allocate across many NUMA nodes, but only treat this as a whole. So yeah, that's, I think that's the best description of that limitation. Is Alexander, is that okay?
Yeah. Yes.
Mm-hmm. Okay, so yeah, so I think we can move to the next slide. Yeah, so we just came with a simple concept to design concept and design to enable cross-NUMA memory allocation. So we treat a group of NUMA nodes as a unit, and we configure such units through a new Kubelet flag. This flag, the name of the flag is cross-NUMA groups flag. And yeah, could we go to the next slide? Because in the next slide, I think this is a more apparent example with more NUMA nodes. So what will be the effect of such partitioning into single NUMA groups and cross-NUMA groups? So the effect is that group 0 and 3 will be used for pods that require single NUMA allocation, and the group 1, 2 will be used for pods that both are not limited to single NUMA allocation and have higher memory requirements beyond single NUMA groups. I don't know if there are any questions to this slide, or is that clear?
I just have a quick question. So a group is just a logical, is a way to group multiple NUMA nodes into one entity so that you can just allocate from that entity that happens to be a group across multiple NUMA nodes. Is that the idea?
Yeah, it is just a logical grouping. Yeah, exactly.
Yeah, okay.
So we could group, for example, as the second group, we could group 0 and 3, but then we end up in the scenario that there is no single NUMA nodes. So if we will use topology manager with single NUMA node policy, there will be no such groups that can satisfy single NUMA policy by topology manager.
So at the end of the day, the way this might work in the end is that instead of asking for a NUMA node, you ask for a NUMA node group that you want to be aligned by, or at least that's what it communicates back to the topology manager in the hint.
If you are asking about hint generation, I will show example in the next slide. So
okay. Sure. Yeah, let's just wait then.
Okay, so there is another but because the groups must be disjoint, because if the groups overlap, this will not ensure guaranteed memory allocation. And here's an explanation. If a pair of groups overlap, memory resources of some group can be prior consumed by another group, so that the other group will starve. I'm not sure if it is clear or not, but when we were designing this future, that was the only way to achieve guaranteed memory allocation through disjoint groups. Okay, I think we can move forward to implementation. Okay, so maybe first I will say a few words about what is not responsible for the memory manager, because this is give a clear view of memory manager responsibilities. So there are various mechanisms independent of memory manager in the node, but the next slides are about to answer what is the relationship between them and memory manager. So the first mechanism is pod eviction that is done by Kubelet, and I will just read. Kubelet can evict a number of pods and reclaim memory after eviction threshold is exceeded by containers. And in the context of memory manager, we use hard eviction threshold because in its design, memory manager adopts a node allocatable feature, which in fact involves also this threshold. Okay, we can go to the next slide. I think the second mechanism is out of memory killer, which is done by kernel operating system. And here, what should be told is that out of memory killer kills processes with the accordance to out of memory score ranking, and low priority containers such as best effort and bar stable are targeted before the high priority containers. So the guaranteed, so the containers in guaranteed QoS class. And what's the implication of that? Is that memory manager will offer guaranteed memory allocation only for pods in guaranteed QoS. Okay, I think we can go to the next slide. Okay, so this is the last mechanism, and it's about obeying C group's limit, which is also done by OMM killer. And okay, in this case, memory manager is responsible for just setting and yeah, that's just setting and updating C group memory limits on behalf of container. Okay, I think we can go to the just
so
to recall.
Before you go to the next things, so there are actually several other means how you can guarantee the memory. So one of the examples can be, well, in OCI spec, there is a possibility to say what container is reserving some amount of memory. We are losing this field if we're looking in our CRI interfaces. So the Kubelet knows about it, but it's not propagating this request memory down the stack. So that can help kernel to pre-allocate or expect what process will collect or use some memory. That's one scenario. Second scenario, instead of like evicting and like killing the process, even though like the best effort ones, like which we consider as the lowest priority, there are possibilities in Linux kernel to migrate pages forcibly. So if you are root, if you have a sysadmin privileges, you can say move pages for this particular process from out of this memory node to another one. It might not fit into current topology manager idea where we do everything on the admission, but in general, like this dynamic reallocation of workloads, it's possible. So there are more than 3 ways of solving this.
Okay, thanks for the summary. But do you think it will affect guaranteed memory allocation, or because
it might free up memory in particular region. So you can fit your new guaranteed container what you are trying to fit.
Mm-hmm. But do you think we are able to track this operation of making the memory free? Because okay, we implemented kind of memory map in memory manager to track what is free, what is the size of free memory and what is the size of reserved memory. And do you think we can track somehow what you just described previously?
It's possible. It's just a bit more work and a bit more extending interfaces in the CRI level. So in OCI level, like down from the RunC or compatible runtimes, we can get that information. And actually from C groups version 1, we can also get for each container how much memory is used per each NUMA node. So you can get to scenarios where you can dynamically shuffling with parts of a memory for a particular container. But again, it's known on the kernel level. It's known on it might be known on the RunC level, but we need to propagate that information up to the kubelet if we really want to use it.
Okay, I see. Okay, thanks for sharing that knowledge. Okay, just back to the presentation. It's just to recall how the world looks like without memory manager. So the common scenario is that Kubelet, when it wants to admit a pod, it queries topology manager, and topology manager gathers topology hints from a number of resource managers. Then hints are merged and container allocated. It means that resources are pre-reserved, and then finally container becomes deployed. Just in how it looks in a nutshell. Yeah, we can go to the next slide, which introduce memory manager. I'll just repeat what I told in the beginning. Just memory manager is a new component in Kubelet ecosystem proposed to enable cross-NUMA memory allocation. It's a new hint provider for topology manager, and hints are intended to indicate preferred memory and huge pages affinity, which pins the memory for a container either to a single or a group of NUMA nodes. And by design, as we said before, memory manager offers guaranteed memory allocation for pods in guaranteed QoS class.
So I have a question. You know, right now the topology manager has a single-numa-node policy, and which generally indicates all the resources are preferred to be on a single NUMA. Now with the memory manager, it seems like you are saying, okay, we can also align conventional memory and huge pages with the addition of being able to allocate huge pages from multiple NUMA nodes. And I'm just wondering, and I think you touched on this maybe in the next slide, instead of having the approach of allocating memory from, or huge pages from multiple NUMA nodes, if the policy is single NUMA node, would it make more sense and fit into the current scheme to still maybe have that ability, but only do that if the topology manager policy is restricted or best effort? Because when I think of topology manager having a policy of single NUMA node, and then we allocate huge pages, from two different NUMA nodes, it's like, that doesn't seem quite right.
Yes, that's right. I mean, here I should also add, besides cross-NUMA, single-NUMA guaranteed memory allocation, because hint, as I will see in the next slides, hint generation includes both single-NUMA hints and cross-NUMA hints.
Yeah, Victor, he said this at the beginning, but I think what he's getting at here is, you know, obviously if you can fit all of the memory that you require on a single NUMA node, then that's what you should do. But if you actually ask for more memory than can ever fit on a single NUMA node, and you don't have the single NUMA node policy set, then you need some way to be able to allocate that for multiple nodes.
Yeah, I totally agree with that. It's just that if the topology manager policy is single NUMA node, I'm really questioning if the memory managers should say, okay, well, I don't have enough on one single NUMA node. I'm going to go ahead and go to the other one and give it to you because there's just not enough.
I don't think he's saying that. My guess is that
okay.
that would be rejected. Yeah,
Okay.
This is specifically about the other policies that aren't single NUMA node. Correct me if I'm wrong, but that's what
I think you're right, because as I remember, topology manager, if it has a single NUMA policy set, it will only filter. It will only accept single NUMA hints preferred,
right,
and will discard other hints. So
right. So I think what all of this talk up until now, Victor, has been about is how can you even set up the bit mask of where you could allocate your memory from. And then obviously the policy will kick in to figure out what to reject and what not. But you need to be able to set up that bit mask to say, oh, this is where I could potentially allocate that memory from.
Okay, got it. Yeah, maybe I misread the slide. We'll get there in a minute, I think. Yeah, thank you.
Yeah, maybe this will be apparent in the after presenting the examples in next slides. We are coming to that point. Okay, I will just summary how it looks like with memory manager in orange. So when topology manager queries memory manager about hints, memory manager first queries its internal database. It's called node map, and in fact, it's this is the object that that is responsible for tracking the memory utilization by keeping counters on free memory and reserved memory. And after retrieving this information, memory manager will in fact provide two types of hints: single NUMA hints and cross-NUMA hints. And then the procedure is standard allocation. So resources will be pre-reserved and then container deployed. So this results in memory manager updating C groups and CPU set mems using CRI API. Okay, I think we can switch to the next slide. So here I just, this is in fact slide on how hint generation is done by memory manager. I just gave notice that cross-NUMA already incorporates single NUMA hint generation. So we just talk about cross-NUMA in the next slides. So memory manager will ensure that the ultimate set of hints includes both single NUMA hints, and here's some example, and also cross-NUMA hints. And as we said before, this is to overcome the situation when the amount of demanded memory exceeds the capacity offered by a single NUMA node. Okay, and now it's something important that all hints that match the disjoint groups configured with cross-NUMA groups flag will have a preferred set to true. And why is like that? The next slide will explain, will illustrate. So consider that we have topology manager running under either restricted or single NUMA policy, and these two policies will admit a container only if the affinity calculation leads to the final hit that is preferred. Otherwise, pod will be or container will be rejected. So this is exactly why we fit topology manager with preferred set to true hints. This is to achieve our primary goal, which is in fact guaranteed memory allocation. So just to sum up, as a result of that, topology manager either provides a best hint that indicates a single disjoint group of NUMA nodes, which is either single NUMA node or multiple NUMA nodes, and this ensures the finite goal. Okay, I think we can move to the next slide. I think this is the last, which that concerns the example. So let's consider a machine that has 4 NUMA nodes, and let's consider that we provided configuration with 3 disjoint groups. So the groups as in the previous example, so 0, 1, 2, and 3, and we generate preferred hints only for these disjoint groups. So we'll have the first hint will be single NUMA hint preferred, which match 0 group. The second one will be cross-NUMA hint preferred, which match 1, 2 group. And the last one is the last preferred is also single NUMA hint preferred, which match the third group.
Can I ask a question here?
Mm-hmm.
So this feels a little strange to me, just because the intention of the preferred flag was to indicate whether that was a minimally possible allocation across NUMA nodes, meaning independent of any allocations that have already happened. If there's enough to satisfy your resource request on some minimal set of NUMA nodes, only those ones should have preferred sets. So it feels weird to have one hint that would have only 1 bit set and a different hint that would have 2. I would expect all of the preferred to have the same number of bits set.
Yeah, but if we will consider, for example, let's first consider single NUMA policy by topology manager. Mm-hmm. Then topology manager will only accept single NUMA hints, so the first and the third one, yes. Mm-hmm. And we'll choose just, I think, the first hint, because I don't remember exactly.
I guess what I'm getting at is, imagine that you had 3 pods come along. The first one does its allocation according to hint 1 that you have here. The second one comes along, does his allocation according to hint 3. Then the third comes along, and the only hint that's still available where an allocation could happen is number 2. I actually want that pod to be rejected. I don't want it to be admitted here, because I'd rather have it land on a different node where it could get all its resources from a single NUMA node, instead of being admitted here just because 2 other allocations have happened on this node already that happened to be able to get it from a single NUMA node, and now I can't. Does that make sense?
So small comment regarding the single NUMA node. In general, this flag not relevant at all, because you don't want to have any cross NUMA allocation when you set topology manager to single NUMA node. So if
I'm talking about even on the best effort or the restricted ones. So even if I'm restricted, I don't want to land here if there is an allocation that could give me a better minimal NUMA allocation, even though other pods happen to be consuming those right now.
Yeah, but we did it because, for example, for CPU, you have some indications that you can group some CPUs together, like you have the same socket, for example. So you prefer to use CPUs from the same socket. For the memory, you don't have such indication, or I'm not aware of it. So we just give to users some additional possibility for the configuration. So if, for example, you want to use some specific NUMA nodes for cross-NUMA allocation, we give the user possibility to configure it before he starts the workload. If he will not configure any of it, like you always will have single NUMA node allocation. That's all, because we don't have any indication how we can set preferred in case when single NUMA node does not respect the request of the container. You know?
Well, again, I don't care about it being single or not single. It's minimal, meaning that if you're asking for, 500 gigabytes on a say 700 gigabyte system, and you've got 350 on each, then obviously the only allocation I could ever do is on those two. This is a bad example because I wanted to actually have more NUMA nodes to drive the point home, but the point being that the minimal allocation there is 2 NUMA nodes, and so that'd be the only reason I would ever set preferred true here, because there could never be a hint that was generated with a fewer number of NUMA nodes. Anyway, we can take this question offline. It's just, the preferred flag was designed to be used slightly different than this, with very specific semantics, so that someone knew that if they were asking for a certain number of resources, it was landing on a node, that they were going to be given the minimal possible NUMA alignment for those resources.
Yeah, just
well, the current topology policy flags, like prefer to single, was only designed in a domain of CPU plus device. It was never taken into account for memory. And memory,
that's true. So I might need to.
It's completely different beast because of distances, because of latencies, and so on. So, like you might have 2 NUMA nodes in terms of memory, but we will be like so close enough. For normal workloads, it will be similar as like single NUMA node.
Right. Okay. Well, we can take this offline. It was surprising to see this, and I'll need to dig into it more and talk to you guys independent. Yep.
Yeah. Sure. Certainly, we'll discuss this offline. And yeah, that's just the third point that contains all hints that not preferred. Okay, we can go to the next slide. We are coming to the summary, and so these new flags are proposed. So just memory manager policy, it's to enable or disable memory manager. The pre-reserved memory zone flag is just to reserve memory for system daemons, and probably the most important flag is the cross-NUMA groups flag that we just described, and it's just to recall to configure disjoint groups of NUMA nodes used for preferred cross-NUMA memory allocation. Okay, and I think that there will be the last slide with the summary. Next one. If we could go to the next slide. So yeah, I'll just present the summary. So in order to enable cross-NUMA guaranteed memory allocation and huge pages, employ memory manager, and also we have to configure containers or ports to be in guaranteed QoS, configure topology manager to be run either under restrict or single-NUMA node policy, use cross-NUMA groups flag to configure disjoint groups of NUMA nodes, and as an option, we can use preserved memory zone flag to preserve memory for system daemons. Okay, I think that's all. So if there are any questions, could we show just briefly the appendix? It just contains some notes on interfaces, communication diagram, and proof of concept. If you could go to the proof of concept slide, just because it contains references to actual up-to-date repository where memory manager has been developed. So if anybody is interested in seeing how it's implemented, just.
Okay, I think that was a great presentation. Are there any questions or comments or more discussions about this? I captured one item in the meeting doc, and it was referring to that Kevin, about the the hint number 2 had the preferred bit that would span multiple NUMA nodes. So just so we capture that and maybe can think about it offline. Any other sort of comments, questions, discussions about this? Kev?
My first comment is really just about phrasing and terminology. So instead of calling it cross-NUMA, I mean, my recommendation would be to call it either multi-node or multi-NUMA. Cross-NUMA has a very typically has a very negative connotation to it, right? Because it usually refers to people don't want to the cost of cross-NUMA traffic, right? So I think what you're trying to describe with the cross-NUMA group concept is really just a provider of some NUMA resources for multiple NUMA nodes. So I would recommend calling it multi-NUMA instead of cross-NUMA for that reason.
Yeah, that's very useful thing about naming convention. I just started naming it memory allocation across multiple NUMA nodes,
Sure.
And in short, I called it cross-NUMA allocation. So maybe that was the
Right. I think single and multi are
yeah. I think. Thanks very much.
All right. So I captured that in the minutes too, also, just so we don't forget. Any other comments, questions, or discussion on this?
Well, my biggest question related to it will be like we need to really think about sysadmin and user experience, how it will be used. So
I was
like,
just going to say that.
Kubelet config with defining the NUMA groups, well, it's possible, but it's not the best user experience, especially if you have like thousands of nodes in your cluster.
Yeah, so I think you bring up a good point. One of the things I'm hoping we can do is allow everyone to present their technical materials, and then maybe we can coalesce them all and kind of judge them from a UX perspective. And I don't know if there's necessarily a one UX fits all outcome, but I do think it's something we need to think about once everyone's had a chance to absorb everyone's perspectives.
And how can be user experience tested within? Can be it tested somehow through CIs or because during the previous SIG Node meetings there was also issues that concerned the user experience.
I think what Alexander is getting at is just to keep in mind that the more flags that are added to Kubelet, and in particular, the complexity of the sort of encoding that the value of that flag has adds a additional weight to the system administrator and deployer's experience. Does that make sense?
Okay. Yeah, and I think I would maybe, I don't know if there's a one size fits all sysadmin for Kubernetes, right? Like if you're running a managed general purpose Kubernetes service, I think maybe some of the concepts Alexander showed on Tuesday's SIG Node meeting are kind of low touch hints that would work pretty well maybe on any general purpose kube setup. I do appreciate that there's like users of Kubernetes who try to make more purpose specific configuration. And so like, it's possible, you know, a 5G telco network would be thinking that the cost of this is worth, you know, the one-time setup, right? And so I don't want to force everyone to be a general purpose Kubernetes distributor when thinking about their UX, as much as just thinking through who is the audience that this is serving, and is it serving that audience well with the right UX? And if we can get to one, that's awesome. I don't know if we will, but I think I don't want to make everyone feel like that there needs to be one and only one UX necessarily, because I actually don't know that. I'm curious if others think there is a one size fits all, but I do think there's a lot of power in Linux that you can configure Linux differently, that like, I don't want to strip all that power in Kubernetes either.
Absolutely. I'm certainly not recommending getting rid of the flexibility and configurability. I'm just more referring to when you have a config option where the value is essentially a JSON encoded array of integers, that it's not obvious, right? What exactly that configuration value refers to. That's all.
Yeah, and I want to clarify my statement. It was like, it's good what we have a configurability. It's good what somebody will be making it like use of it. The question is what, like, we like to enable the feature, we should not require everybody to do it or everybody to configure the same thing. So like for majority of Kubernetes users, it should be like some sensible defaults which everybody will be able to use.
Okay, I just want to do a quick time check. There's about 5 minutes left until we're out of time. There was another topic on the agenda today that we're not going to get to, and so there's these questions we want to ask. Have we triaged all the open proposals or topics? And the answer to that is, of course, no. And do we need to meet again? And I think the answer is yes on that. So do we want to meet sooner? Or do we want to wait a week to meet and go over the pod level single NUMA policy, or do we want to try to meet sooner?
And also, what is the action items coming out of this? Do you guys want comments on the presentation or the KEP or both, or what's the ask here?
I think the KEP is preferred.
I think, okay, the presentation is, I think, a great summary of the KEP. And in fact, I will be still working on KEP to improve the clarity of text and its coherency. So yes, I think this presentation can be treated as a part of KEP. So because it exactly represents what's the KEP is about. So yes, as Artemov said, we would prefer to have the review of KEP in the first place.
Okay, yeah, that's a good point. I sort of missed that. We didn't actually go over the KEP. So do we need to do that in a separate meeting, or do you just, is it okay for folks to review offline and provide comments? I think, Jay, you had a good point there. We've talked about this. We looked at the presentation, and what's the next step? Do we take it back to SIG Node, or are we ready to present? Or I think what I'm hearing is that we need to review KEP, provide comments, and then revisit this again. I'm not sure.
Yeah, I think if it were me, I'd like us as a smaller subgroup to kind of like provide a coherent perspective back to the broader SIG on these are the 5 or 6 things we evaluated. We think these 2 meet this use case. We think these other 2 meet this other use case or maybe other target consumer. And, you know, I think the comments on this is good. I think what I'd like to also see as the next step is like contrast this with the work that was presented on Tuesday and ask like, are they serving the same audience? And if not, should they be pursued orthogonally?
Okay. All right. Okay, with that, then I think
We never answered your question if we wanted to meet before next Friday or Thursday.
exactly. So any thoughts on that? Do we want to meet or wait another week before we meet and review the Chris's and BG's topology manager pod level single-numa-node policy, or?
I mean, I'm happy to meet sooner as long as it's around this same time.
Mm-hmm.
When it starts to get later is when it gets harder. I mean,
So I would propose, we were, you know, Kevin, we were meeting on Tuesday mornings. We were meeting earlier. That might be an option if we want to do this quicker. I think it might be more, get some input from Derek, because I think we certainly want his.
Yeah, I think Tuesday morning's fine. Like I said, I'm really just trying to unblock progress, and I think it's important we hear everyone present. And so if you want to meet again Tuesday and then we'll have the normal SIG meeting again in the afternoon, that's fine too. I want to get through the backlog and be respectful of everyone's time and energy.
Okay, so would this coming Tuesday at the same time work for everyone?
Works for me, but I'm on East Coast, so.
Yeah. Okay, why don't we propose that, and the next meeting will be and we'll go over the topology manager cap that's down here, and I'll fix that and send out an invite. Does that sound good?
I could just quickly add something. I just wanted to ask for an offline review of the cap on this meeting, and I think if you could go through that, we can discuss maybe the results on the next meeting. I just wanted to ask for a review and not go through the cap, because the CAP's update is relatively small to the memory manager. It is only one policy, and it is not much things in it, so it won't take long, in my opinion.
Okay, so you're thinking we don't need to have a meeting Tuesday to go over this and just review it offline and talk about it in the meeting on Thursday, 1 week from now? Is that what I heard?
Maybe, but let's get back on that on the Tuesday meeting. I don't know if it will be the subset meeting or maybe the SIG Node meeting, because I wanted to mention that also on the SIG Node meeting, but there was no time.
Okay. All right, so I guess what I'm hearing then is just review this CAP offline. We don't need a Tuesday meeting to go over this, and we'll just meet regularly on the next meeting will be Thursday at the same time. Am I hearing that correctly? Everyone agree?
In my opinion, it's all right.
All right. Okay. That's what we'll do then. We'll just have the next meeting for a week from now. And I think that's it. Derek, you want to stop the recording, and are we done?
Yeah, we'll do. See you all Tuesday morning. Thanks again.
All right.
Perfect. Thanks very much.
Thanks, everyone. All right.
Thank you, guys. Bye.